Now we're ready to look at lesson 9.2, day 1, characteristics of quadratic functions. Given a parabola, again that's the graph of a quadratic, I can find the zeros and find the axis of symmetry from the vertex or zeros. Our vocabulary, we have zeros of a function, x values that make the function equal 0, and in an equation what you'll notice is that f of x or y will equal 0. We don't know that x is 0, we just know that the output is 0. And there are three terms we typically use: zeros, roots, and x-intercepts. Graphically, you'll notice zeros of a function as the place or places where the graph crosses the x-axis. If you look here, this is the graph of a parabola. It opens up, crosses the x-axis at -2 and -6. That means the input produces an output of 0. The axis of symmetry, a vertical line through the vertex that divides the parabola into two symmetric halves. That means that if you could draw a vertical line through the vertex, you would notice that the graph is identical on either side. So there's symmetry to the right or to the left of the axis of symmetry. Finding zeros from a graph, a quadratic function may have or will have 1, 2, or no zeros. The blue graph is an example where we have 1, 0. That means y is 0 and the value of x is -7. If we look at the red graph, we see there's two zeros here. -3 and 2 are the zeros, the values of x that make the function equal 0. In this green one here, we see that the graph comes down and then turns around and goes back up before it even hits the x-axis. So in this case, it never crosses the x-axis. There are no zeros. To find zeros from the graph, what we'll see is fairly obvious. We see when x is -1 and when x is +3, we get a y value of 0. We're on the x-axis. So if we were to try and plug in -1, we should have this equal 0. Well, -1 squared is +1. -2, -1 is +2. 1 plus 2 is 3. 3 minus 3 equals 0. Sure enough, -1 is a 0. Okay. Another 0 would be, we would predict, 3. If you plug in 3, we see that we get 9 minus 6 minus 3. That's 9 minus 9. Sure enough, 0 equals 0. So our zeros are -1 and 3. Often we write it as -1 comma 0 and 3 comma 0. You can do it either way. We typically show it as an ordered pair to make sure we see that the y is 0. Find the zeros of this graph. Go ahead and try this one on your own. Okay, you'll notice that 1, 2, 3, 4. 4 to the left, or -4, we would think is a 0. So we get +16 minus 32 plus 16. Two 16s add up to +32, minus 32 is 0. Sure enough, -1 is a 0. Go ahead and hit pause and try this one. And now we look at this graph on the right here. Notice that it never crosses the x-axis, therefore the y value goes from -infinity, it comes up, gets to -2, and then goes back down. It never reaches 0. The highest it gets, its maximum, is -2. Never quite gets to 0. There are then no zeros for this graph. Finding the axis of symmetry, another important aspect of a parabola. You may be asked to use the vertex or the zeros to find the axis of symmetry from a graph. It'd be nice when we can notice right from the graph what the vertex is, and then through that we can use the information about what the value of x is to get the axis of symmetry. The axis of symmetry must pass through the vertex, and it lies in the exact middle of any zeros, and we can use that to find the axis of symmetry. So the axis of symmetry uses the x-coordinate of the vertex. In the example on the left here, the vertex is fairly obvious, -3, 0. the axis of symmetry is x equals -3. The vertical line, x equals -3. Likewise, if the zeros are easy to identify, we can, like this one, we can guess. But if we use the zeros, what we find is you can find the average of the zeros to find the axis of symmetry. The axis of symmetry is going to take each of the roots or zeros, add them and divide by 2. That'll get the exact middle. 5 divided by 2 is 2.5. So we would say that the axis of symmetry is x equals -2.5. And we could have estimated that, but we want to verify it, and having obvious zeros, we can do that. And now you're ready for the on your own. Here's some graphs. Estimate what you think the zeros are, the x value. Plug it in and see if you get y to equal 0. We'll see you in class.